Hi, good afternoon, very warm welcome to you. I'm back, guys, and I thought I would do a latest position of the magnetic North Pole for you. I know that we normally do it every 17th of the month or on the end of the month now is what we've been doing, but we've had to, because of my trip recently, leave it an extra week, so there's 3 weeks worth of migration that we've calculated for you. You can see the latitude and longitude there: 81 degrees, 58 hours, 1 minute 5 seconds north by 115 degrees, 41 hours, 39 minutes 39 seconds east, and it has moved, as you can see, a total of 1.3 miles. Now you might think that it's slowed down. What you've got to remember is we normally now do a magnetic pole positioning for you every half of the month, but we've left it for just a little bit longer this time by another week, and that's why it's moved or migrated, that distance of 1.93 miles. It's still tracking west. I'm going to zoom out for you so you can see what's the direction, where we're heading. We know why. Obviously you're going to be interested in where we are on that theoretical 40 degree mark, so let's get on with it. Let's get that sorted. So I'm just going to back out Google Earth so that you can see yourself where the 40 degree mark is. You can also see, if I back out, that where the magnetic pole is at the moment is just over now the North Atlantic ridge, and you can see our corridor of the white and yellow line there tracking right to central Russia. And one thing that has been going through my mind is how much has our magnetosphere weakened at this point, because we knew that a few years ago it was pretty much stable in that it wasn't deteriorating that much, probably 15 to 20, maybe 23% reduction in the magnetosphere strength. It'd be interesting to know, other than what we know. I mean, first of all, we know that as the magnetosphere weakens, it allows a lot more cosmic rays into the upper atmosphere, and when we collect the muon data, what we're actually receiving at the muons is the collisions that have happened in the upper atmosphere. So but my question is, other than cardiac arrhythmia that can be affected by an increase in cosmic rays, and obviously more cosmic rays or more radiation causes cancer, but what does it have effects on the mental capacity of human beings and other animals? Because if we've been, for the last 780,000 years now, used to being protected by, a magnetosphere at full strength, and now all of a sudden it's started to weaken, then I would believe that would have, probably effects on the mental ability of people. But with regards to that, it's uncharted territory. It's like a lot of things that we cover here, especially when we're talking about climate and things like that. There are so many variables that can affect it. It's like I could argue today here in the UK that we've had a ground frost, in late April. Now it's not uncommon to get that, but how do we know whether it's caused through an increase in clouds as a result of more cosmic rays and the temperature just isn't penetrating the surface, or is it because we are returning back into another glacial period, and probably 6,000 to 8,000 years already into the Milankovitch cycle? So when there's a lot of different variables, it's very difficult to make predictions. And let's face it, climatologists have been trying to predict the weather for the last 150 years, and even they still get it wrong. But when you think about all the things that are taking place now, like with the ground frost that we had here in the UK today, and it's set to go to 0 again tonight, you know, you've got to start wondering how much of an impact this is going to have on crop productions in Europe. And, you know, with the changing jet streams that we've got, interactions with the polar jet streams and subtropical, both over the northern and southern hemispheres, it makes you wonder, you know, how much impact is being had through, you know, a few of these things like climate, extra cloud cover, you know, the weakened magnetosphere. It makes you wonder how much, you know, we can sustain losses with regards to the crop productions around the world. And you guys know as well as I do, because you look on other channels and you know that there are massive crop failures taking place now more than ever, but there doesn't seem to be a real reason given by, you know, mainstream scientific organisations or media as to why that is. But we know that the land, you know, arable cropping land, good quality agricultural land is going offline because the climate is changing. So yeah, I thought I'd you know, just show you where we was on the latest positioning of the magnetic north poles. What I want to do over the next few days is just show you some of the equipment that we use, like the Trimag system, you know, the muon detectors, the CO2 you know, equipment that we use to collect that, and a few of the things that we do to provide a little bit of a service for you guys. So if you go onto the website, what I tried to do with the website, and it's sometimes difficult because it's just me, I would love the luxury of having, you know, a couple of people do this with me, and I'm really happy that we've got, you know, amazing people in places like the United States and Canada that do collect magnetometer data and muon data for us. But I would like, you know, to have probably a couple of people here helping me, you know, like when it comes to, I mean, I wanted to update some of the equipment that we've got and make it, you know, like I wanted to incorporate the magnetometers with the muons in one 3D printed box. And to do that, I'd have to, you know, do some programming, and it'd be nice to have someone write the code for me, as opposed to, you know, not only designing the you know, the boxes that this stuff goes into, but also having a bit of a help with the programming and a few other things. It would be nice. But, you know, we do what we can here for you guys at the observatory, and we've been doing it now for 10 years, haven't we? You know, and we're very close to possibly seeing something take place when the poles arrive at that 40-degree mark. And remember, it is just a theoretical mark based on the experiments that we've done. And, you know, I try to show that experiment more often there than I used to, because it helps people get an idea as to what we're talking about and why we've selected that 40-degree region. I think when you look at the experiment that we've done, very simple experiment, you get a better idea of what's going on. So guys, I won't keep you any longer than what I have to. I'll just say a huge thanks to those few people that have been supporting us over the last few weeks. And, you know, if you want to help, you know, in gathering the information and making it possible for us to do what we do here, there is a link down there in the description. And there's nothing more to say other than, guys, it's not mandatory. You don't have to, but simply if no one helps, we will come to a grinding halt here at the observatory. And like I say, you know, when you've done 10 years worth of research on this topic, it would be you know, a real shame for it to stop now, when I believe things are going to start getting a little bit more exciting. So yeah, the link's down there if you want to help support us. And the only other thing to say is, guys, you take care of yourself, your loved ones, as always. Bye for now.